Hello students, welcome to my class Learn with Ali. So in this video we'll learn delta modulation using the MATLAB. So before going to the MATLAB code, I would like to first introduce some theory part. That's why to understand the code it will be very easy when you learn first theory part. If you know the theory part very well, then you can skip the this session and just jump to the MATLAB code. So in delta modulation, as you see here, the block diagram of delta modulation is represented by this summation part. Here it is sum and this is minus and this is 1 bit quantizer. So delta modulation is nothing but DPCM, 1 bit DPCM. DPCM means differential pulse code modulation. So I have already explained the PCM, that is pulse code modulation, in previous videos. So in this video, DPCM I have not explained, but I can explain here, that is DPCM. What is it is going in DPCM, differential pulse code modulations. It is encoding like PCM, but it is encoding the difference of the current pulse minus the previous pulse. So this is the differential pulse code modulation. So current pulse minus previous pulse or sample, current sample minus previous sample. It will give you the differential part, and that is encoding with like the PCM. So in PCM there is n-bit encoder, but here in delta modulation it is 1 bit encoder. So only if there is n equals to 1, that means L equals to the power n, that means n equals to 1. So 2, only 2 labels is there, that is one is plus delta and second label is minus delta. So let delta equals to 0.1. By taking an example, I can explain this block diagram. So let this is the sinusoidal signal that I have to this delta modulate this sinusoidal signal. So first it is going through the sample signal. So this sample signal, before this summation there is a sampler. So that sampler gives you some sampled signal of this sinusoidal signal. Let this sample value is 0.2, 0.3, 0.5, then again 0.3, 0.2 and 0.1, like this, because it's going upward from here to this point and then downward. So this is the samples. So first here it is 0 when there is nothing in the feedback, then let assume it as a 0. So when this the first sample 0.2 volt comes here and this 0 is minus 0.2 minus 0, it will give here it is 0.2. And if this quantizer, there is only 2 labels, if this value is greater than 0, then it will give it here it is delta, and if it is less than 0, that is negative, so it will give you minus delta. So in this case when it is 0.2, it will give you delta, and we have assumed that delta equals to 0.1. So and if this is delta, then encoder, what the encoder does, it encodes the, if it is plus or delta, it will give the output as 1. Either if this is minus delta, then it will give the output as 0. So this delta goes this portion and this 0, so 0 and plus delta, this propagate to here delta. In the next cycle here it will become delta. Delta means 0.1. So for in the next sample, when the sample is 0.3, the next sample 0.3 minus, now it is not 0, now it is 0.1, that is delta, that is propagated through this block diagram. So this is now what you can say here, 0.3 minus 0.1, that will become again 0.2, and here it will give you plus delta, and this will give you 1, and here it is already there is a delta, and from here it is plus delta, so it will become 2 delta. Now here it will become 2 delta, that will become 0.2. Now next sample is let 0.5. So here it is 0.5 minus 0.2, that will give you 0.3, and this 0.3 by the quantizer it will give you plus delta, and here it will give you 1, and this point it is 2 delta and plus delta, it is now it will become 3 delta. This propagates here 3 delta and it will become 0.3. Let it is 0.25, like 0.25, like, so here 0.25 and here it is 0.3. Now this will become more or greater than this input, so it will give you minus 0.5, that is negative. And here in this part, here it will give you minus delta because it is minus, and corresponding to this minus delta it will produce 0. And this minus delta, 2 delta, 3 delta, here from this it is 3 delta. Now 3 delta minus delta, it will become again 2 delta, it is reduced, so it will become 0.2. Again when it is so let take it 0.15, 0.15. So when it will become 0.15 and minus 0.15 minus ka 0.2, it will give you minus ka 0.05. So when it is negative, then again it is minus delta and it will give you 0. Similarly, and it will become plus 2 delta minus delta, here it will become only delta, and again it will become 0.1 when 0.02, like this. So this similar pattern is going on, and here it is delta modulated signal, that is in the form of 1 1 and 0 0 0. So for the demodulation part, let's go to this block diagram for the demodulation. So after delta modulation, you are getting the signal in the binary system, that is 1 1 0 1 1. If this is the sequence, if this is, if this may be 1 0 1 1 and 1, it is the binary bit sequence. So the first block diagram is decoder. So decoder is nothing but when it is 0.1, it generate plus delta for the 1, and when it is 0, it will generate minus delta. And again here it is plus, not minus as in the previous one, that is in the modulator circuit. Here it is plus. So first let assume it is 0 because there is no memory component, and this part either it will give you plus delta or minus delta. Then again passing low pass filter, it will, what is the output, let's explain by this. So let assume that is here it is 1. That means for the 1, when we are transmitting, it will become plus delta, it will decoder generate plus delta, and plus 0, delta plus 0, it here it is delta, and this delta we have already assumed that delta equals to 0.1. So passing through low pass filter, here it will give you 0.1. This is the sample which is 0.1. Its value is 0.1. Then again it is 1, the second one. For the second, this is plus delta, and now here it is delta, so it will 0, it will become delta. So delta plus delta, it will become 2 delta. Now here it is 2 delta, so here in this it is not exactly the same, 0.2, because delta is 0.1, so it is 2 delta. Again it is 0, so it will give you minus delta here, and it is already delta, so minus delta and delta. So if this 2 delta propagates here, it will become 2 delta. Now minus delta plus 2 delta, it is only delta. This is first time slot, this is second time slot, this is third time slot. Only delta means here this sample is we are getting. Similarly 1 1, that means again it is 2 delta, and then again it is 3 delta. This type of pattern you will get. So passing through the low pass filter like this. It is just an example when you are taking the sinusoidal signal. So it will go up like 1 1 1 1 1 0 0 0 0 0. This type sequence you will get. From that you will get 1 delta, 2 delta, 3 delta, 4 delta, 3 delta, 2 delta, 1 delta, and 0. This type of, when you pass through the low pass filter, it will give you the low pass filter is basically smooth the signal, right? So let us go to the MATLAB code. So here let's discuss this MATLAB code. So first, that is CLC, clear and close all. These are the syntax you already know when you have watched my previous videos. So here A nothing but amplitude of the signal. That is, I am generating a sinusoidal signal in which the amplitude is 2 I am taking, and t is the time axis which is going from 0 to 2 pi. I am taking 2 period means nothing but like if this is the sinusoidal signal, so this is 1 period and this is 2 period. Up to here this 2 period is taking, and 50, this 50 is number of samples in a single period. That means one sample, second sample, third sample, fourth sample, this type of samples, number of samples is given by 50. So x equals to a sine t, it gives to this, that is mt. You can say this is mt, or you can say this is the modulating signal, the signal that we want to modulate in delta modulation. So subplot 2 comma 1, I have to plot the signal. That's why I have used this subplot. So I'm plotting the first this signal. How to plot the signal I have already explained in my previous video. So if you are any confusion with regarding subplot, plot, hold on, etc., you can watch my previous videos first. So here, as I have already discussed that, suppose delta is some value. So let here I have assumed that delta equals to 0.25. This is the same delta as I have already explained in the theory part. So xq equals to 0. Xq is nothing but the quantized signal, or you can say that yeah, this is just quantized signal. After the quantization, this was the block diagram. So there is the quantizer. After quantizer, this part is denoted by xq, right? Here it is encoded, and this again, this is summation part, and this summation comes from here. Then again, this is delay. Remember the block diagram of delta modulation. So if this is going from, we are going from uh, x and t, x and ts, that is first sample to last sample. That means how many number of samples that can be given by this length of x. If xi is greater than xqi, xqi is nothing but this xqi here. If this part is greater than this is minus, this is plus, so this is basically comparator, then here what will be, this is give you the positive plus delta, right? So di equals to 1, or this is the for the encoder. You can skip this here, you can write here this part and first this part. So xq plus 1 equals to xq plus delta. So we are this is xq, and xq plus delta, this is xq plus delta, and give me again it will give you xqi. So quantize, this is just this part, this part is here. Else di equals to 0. If this is negative, so you can get it minus delta, and this will encoder will give you 0. I have already explained this theory. And xq plus I plus 1 is equals to xqi minus delta. That means here if this is minus delta, so this is xqi, so xqi minus delta, this will propagate here, that will give you xqi I plus 1, the next sample. So this is the simple code of delta modulator part. Let's go to the demodulation. So I have plotted the stairs. Stairs means this, the output is plotted like this. Stairs means the output plotted like this. That means this is the first sample and this is the second sample, third sample. So this is like plotting like this. This is the staircase plot. So then demodulation equals to 0. When you see the demodulation part, that is it is delta or minus delta. Before this there is a decoder, and before this there is 11001, and this is the summation. Here you will see this is plus, and this is, here it is delay part. So demodulation equals to 0. Demodulation means here the signal which is represented this, it is 0 first. And if di equals to 1, that means what is the signal it is? If it is 1, then what it will decoder pass? It is plus delta, right? So demodulation I plus 1 equals to demodulation I, which is already 0, plus delta, because it is 1, so it will generate plus delta. So these two are summed, are added to each other, and here it will this demodel plus delta, and this pass through the low pass filter. Else, if this is 0, that will generate you the minus delta. So this is already demod. We have represented this signal as demod. So demod minus delta. Here you can see, and end. This is just this representing this whole part is representing this. Low pass filter is nothing when you plot this signal, not like staircase. Just plot the signal in MATLAB. So it will be have like a low pass filter, and it if this is the samples, 3, 4, 5 samples. Only this is the samples, and you plot in MATLAB. So it will take like tip of all the samples, and it will plot this. So that is why we have not passed through the low pass filter. It is equally same as the plotting the signal. And after that, we have plotted the demodulated signal. X label is time, Y label is amplitude, and this is delta modulated signal, and nothing, it is just plotted. Axis, we have defined that x axis from 0 to 51, that is we have taken the 50 number of samples is 50, that is why it is more than number of samples, one more than number of samples, 0 to 51. And a equals to amplitude of the signal, so we have plotted to visualize the signal in sinusoidal signal, a plus 0.2, and this is minus with and a plus, that is the we have scaled the y axis and nothing. So from here to this part, it is nothing but plotting of the signal. So let's run this program and see what is the result. So you can see this the I'm getting is so this red one, this red is representing your original signal, or you can say this input signal, and this green part, which is the demodulated one. So you can say here, you can say there is, this is the some causing error. This part is causing error in this part. It is not like the same. And again, this part is causing error. And this is the delta modulated signal. This is one. So time duration is TB. This is just it is TB. This time duration, you can say it is TB. So this is 1 up to 10 samples. Then this is 1 0 1 0 1 0 1 0, then again 1, and this is 0 0 0, like that. So, and this is the staircase which I have plotted is delta modulation. So you can say you can see this is the step size, that is delta. So in this delta modulation, there is two types of error. You can see that when the message signal amplitude, like this message signals slope is greater than this slope. This slope is delta upon Ts. So when the slope, this delta by Ts is greater than empty, slope of empty, message slope, then it is called granular error. When this delta upon Ts, this is the slope of delta modulation is less than slope of MT. Slope of MT. MT, what is MT? This red signal is represented as MT. So in this case, it is called slope overload. Slope overload error. Right? So here in this, what we are getting, the masses signal slope is greater than the this slope, which is represented by green line. So here you can say that there is slope overload error is occurring here in this part. So in this part, slope over error is occurring. Here, this is also in this. If you reduce the delta or increase the delta equals to 0.25, we have assumed. So let's increase the delta, which is 0.25. Let it is 0.5, or let it is let 0.5. Then again run the program. You can see there is a difference. Here you can see at some parts in this region, this slope is greater than this masses signal slope. Let's discuss it. This slope, masses slope, is less, and the delta DM modulation slope is greater. So here it is granular error, and in this part the masses slope is greater. That means here it is the slope overload error. So I think it is, you understand the things what I want to try to say. So if you have any problem in the code, to understand the code or anything else, you can comment in the comment section. This is the simple code which is very easy. I have explained in very simple way, and if you go with the theory, then it will be easy for you. If you like the video, then please like, subscribe and share.